Welcome back from spring break into this new chapter 8. The idea here in chapter 8 is called hypothesis testing, and it's well read in the book. I wanted to give you an overview of what's happening here. So what I meant by well read in the book, I think it's well described as you read through the book, but I wanted to give you my own take on it and highlight the important pieces. And so I thought it'd be helpful to start with an overview of what's happening. And so the key word in what we're doing is the word hypothesis. So what a hypothesis is, it's really an educated guess, right? A hypothesis is not something that you know, it's something that you are believing is true based upon experiences that you have. And so our job is to look at a situation and read what they are claiming. That's often how a hypothesis will be expressed. They'll talk about a claim. Hey, we're going to claim something, but they're never going to claim it based upon nothing. It will always be based on an educated type of decision, meaning that you have some data to support it. Now, the question really then is our data strong enough? That's what you're measuring. You're essentially saying, is the data strong enough to support the claim? To support the claim. Get rid of that. That's what we're looking at. So we're going to be testing, right? We're going to be measuring whether a hypothesis can be supported or not. But you would never make that hypothesis without seeing some data. Now I say you'll never make it, but we're not going to be the ones that are making the hypothesis. The hypothesis or the claim will be given to us in every problem. The data that we need to support it will also be given. Our job is to know how to go through and test whether the data is strong enough to conclude that the claim is true or potentially the claim is false. So here's what a typical question looks like. It's down here. We have a question that's here about 10 students. So we surveyed 10 students and found that 70% have enjoyed having their face-to-face class changed to online instruction. At the 0.05 level of significance, tests the claim that more than 65% of students have enjoyed the transition. That's what we're going to be dealing with. We're going to be dealing with a problem that's that small, that compact, and our job is to test it. And so I wanted you to see what an overall problem is going to look like. This is a problem that's found in 8.2, and a very similar one will be found in 8.3. We're not going to be doing 8.4 as a class, so hopefully I'll communicate that well in other avenues. So we're just going to be doing 8.1, 8.2, and 8.3. And what 8.1 has us do is practice with this overview, because there's several ways, or several parts I should say, in order to test a hypothesis. And so I want you to take a look at this. We are surveying not so many students. If you look at this, we're only surveying 10. 10's not that much. It may be enough, but take a look at what we're claiming. We're claiming that 70% have enjoyed having their, we're seeing that 70% have enjoyed having their class change. We're claiming that then that would substantiate that more than 65 are doing it. So our claim would be that the proportion of all FLC students, or all students in general, I guess I didn't qualify them, that are enjoying the online transition is greater than 0.65. That's what it looked like in symbols. And our 8.1 gives us a chance to practice with that, and then you'll be doing this in every problem in 8.2 and 8.3. So we're going to test this. We're going to test it by looking at the strength of the data. But we're only considering 10 students. That may not be strong enough for us to make a claim like that. Notice that we'd have stronger data if we got the same numbers out by talking to maybe 100 students. 100 students, if we got the same 70%, that would be a stronger position to say that we're more than 65. The 10 might not be strong enough. There might be too much error involved with only dealing with 10 students to ensure that it's above 65%. And so we're going to be measuring whether our data is strong enough to make the claim to establish the claim that we're making. Notice that our claim, though, is always in accordance with what we're seeing in the sample. We saw 70% come out in the sample, and so we're using that to say more than 65. That should always be the case. The only times that that's not going to be the case is if you're testing somebody else's claim. So maybe you have a claim like, hey, Sutter Memorial says that they have an average wait time in the emergency room of 15 minutes. But your experience and the experience of family members has been different than that. You run and check the numbers, and you find that maybe the average wait time of the people you randomly selected was 35 minutes. So you're going to make the claim that you're going to test the claim that they're making that it's 15 minutes and say, well, that's certainly not the case, and you would debunk the claim. That's going to happen sometimes as well. So the point of this is just to tell you what's going to be happening. You're going to be testing a hypothesis. You're going to be given some data, and then also a hypothesis or a claim. And then your job is to test, is that data strong enough? And sometimes you'll find that it is, and sometimes you'll find that it's not. When you find that it's not strong enough, you're not making any set conclusion. It's pretty left open because, for example, if we found that 10 was not strong enough, we'll essentially say that we don't have enough information to establish the claim. That doesn't necessarily mean the claim's wrong. It just means, hey, go out and talk to more than 10 and see if your numbers stay above 65. Because right now I'm not sure that they are. If they do, we might find very well that we have at some point enough data to say that it's more than 65. We're just saying not at this point. And so it's a very weak statement when you're not able to say that the claim's strong enough or the data is strong enough to support the claim. So keep that in the back of your mind as you look at other principles that are needed in order to solve these problems.